Hello and welcome. Today we're going to look at linear regression and we're going to try to understand it a little bit more intuitively. First off, we look at the formulas, alright? I know it's a bit overwhelming at the start, but when you kind of understand what's happening, it's just going to look like a step-by-step view of everything that's happening. First off, we have y is equal to mx plus c. So y here is an output variable, right? And x here is an input variable. So what we do is we give x and process it using something. Then we get a y variable. That's the result of this processing. So how do we process it? We have two variables, m and c. So what is m and c, right? M is basically the slope variable and c is the intercept variable. M is the entity that dictates what angle your prediction line or your relationship line falls in. So if I start a prediction line from here, m dictates or the slope dictates what the angle is going to be. We want a slope that is ideal in a sense that if I use that slope value, the relationship is going to make sure that every point has an equal pull on the line. So I can't use something like this. I can't use something like this either. It has to be something in this region, something that gives equal weight to all the points like we've discussed. Next up, intercept, right? So intercept is basically the offset of the line. I'll just use a freeform selection here to help you understand a little bit better. So we've selected the line, right? So basically, the offset handles this function, dragging the line up and down. That's what the offset actually does. So what we have to do is figure out a good starting point for the line, as well as figuring out a good angle for the line, as we've discussed. How do we calculate slope and intercept? We already have formulae for calculating the slope and intercept using the ordinary least squares regression. Alright, so let's try to understand the formula. M here is the slope variable that we're calculating, and n here is the number of elements. So if I want to explain it better, in this x array, the number of elements would be 5, right? Next up, we have the summation xy variable, this section of the formula, which means that I'll multiply the first element of x with the first element of y, then take that value and add it to the multiplication product of 3 and 7, then the multiplication product of 5 and 8, then the multiplication product of 1 and 3, then the multiplication product of 6 and 8, and so on. Next, summation of x, which is the sum of all values here. Next is summation y, which is the sum of all values here in the y array. And next is the summation of bracket x square. Take the sum of the square of each value individually. So I'll take the square of 2 plus the square of 3 plus the square of 5 plus the square of 1 and so on. Next is the summation of x, the whole bracket squared, which means that I'm going to sum up all the values of x first, then square it at the last. So I'm going to take 2 plus 3 plus 5 plus 1 plus 6, and that value will be squared. That's the summation of x, the bracket square. Next up is summation y, which is basically summing up all the values in the y array. And yeah, I think that's about it. We've covered all the variables. Now let's take a good look at the code and the implementation to understand it a little bit better, logically. First off, we import two libraries in Python, NumPy and Matplotlib. NumPy helps us to handle arrays a bit more efficiently, and Matplotlib is just for data visualization. We initialize two arrays, x and y, as NumPy arrays of course. 2, 3, 5, 1, 6 is the x array, and 6, 7, 8, 3, 8 is the y array. Next, what we do is we initialize all the variables that are a part of the formulae for the slope and intercept. If you look carefully, you can see summation of xy, summation of x, summation of y, variable n, and all those other variables. So summation of x is shown here, summation of y is shown here, summation of xy is shown here, and summation of x square is shown here as well. And these are all the variables that we need for calculating slope and intercept, right? So we have the formula plugged in here. The slope formula here is the same as this formula here. The intercept formula here is the same formula as this one. So now we've basically calculated m and c, right? Next, what we do is we initialize a new variable called y prediction. So now we can get a good relationship built with just the x array. We do not need the y array anymore. We've already formed a proper relationship between x and its supposed y's. So the model understands if x is this value, y is supposed to be this value, right? Which is shown here. We print out the prediction values and we can see that for 2 the actual y value is 6, right, as shown above, but the prediction is 5. Since our values are not strictly linear, there's going to be a little room of error as well. So what we do is we scatter all the values using a scatter plot. The blue dots indicate the x comma y values as shown here, plt.scatter x comma y. So 2 comma 6 is 2 comma 6 as shown here, right, and all the values follow the same thing. Next, what we do for a little bit of better understanding is we see this red line here, right? This is the actual relationship line. What we're going to check is whether the predictions for x actually fall on y. So what I'm going to do is I'm just going to create another scatter plot using x and the prediction, right? So I'm going to take the value 3 and the actual value is 7. However, I'm going to use the value 6.04 just to show how the predictions are plotted by the line, right? So I'm going to plug in here 3 and 6.04651163, and I'm just going to give a color black to see it better. As we can see here, the predicted value for the x value 3 lies over here, exactly near 6.604. That lies on the line, which means that if we take a prediction of any x value here on this axis, it's going to lie on this line over here, right? So we've essentially just built a small miniature model that understands the relationship between x and y variable, x being the input, y being the output. So if you have directly linear variables such as higher temperatures leading to higher ice cream sales, it's going to follow a similar trend. Not necessarily strictly linear, because in real life, models rarely follow a very linear pattern, because nothing is uniform, right? Nothing in life is uniform. Nothing in practicality is ever uniform. This is just for an understanding of how a model may build relationships between two variables. And I hope that you've understood how the formula works and why it works, and what the slope does, the angle of the line, what the intercept does, the offset of the line from the base. And as always, keep learning, and curiosity is the only thing that's got us this far. And I'll see you guys in the next one.